Here's another exercise. Find the area of a circular sector formed by a central angle of 10 pi over 9 radians and a circle of radius 10 meters. And what we got to realize here is that this is a question about area of a sector. And that's very different from the arc length situation. Back on our geometry review, we had talked about arc length versus area. So we're going to have to use this area type of setup here because that's what we want. We want area. Let's try to get a picture drawn here. Now we have a sector of a circle. We don't know how large this sector is. You're just drawing a hypothetical picture. I can see this is a really large sector. It's even more than half a circle, but you don't have to see that to solve this problem. You can just draw any kind of picture. So it's this area that we want. Not the arc length in this case. Okay, again, don't worry if you didn't see how large this sector was. And let's see, our radius is 10 meters. So because this is an area problem, we cannot use arc length. We cannot use the radian measure formula because that only involves arc length of a sector. So for area, we got to rely on a proportion. And I'm going to use radians, so instead of writing degrees on the right hand side, I'm going to just use my right hand fraction theta radians over 2 pi radians, which is full circle measure. I think there might also be an area formula in the textbook, but don't memorize area formula. I don't know. I just don't think that's that helpful. I think it's better to learn how to use a proportion than to memorize a whole bunch of formulas here. So let's see. So let's let maybe x equal the area of the sector. So if I set up a proportion here, I'm going to say x, the sector area, over the area of the circle is equal to, I'm not going to use degree measure, I'm going to use radian measure, the radian measure of the sector, 10 pi over 9, over the radian measure of full circle, which is 2 pi. Instead of 360 degrees. Now, if you really wanted to use degrees, you could convert the radian measure to degree measure and then set up a proportion with degrees. That would work just fine. So I need the area of the full circle here. The area is pi r squared, which is pi times 10 squared, or 100 pi square meters are the units of area. So that's what I got to plug into my proportion that I'm setting up. X over 100 pi equals 10 pi over 9 over 2 pi. And I could try to clean up the right-hand side of that. 10 pi over 9 divided by 2 pi over 1. I'm just going to carry out that division, and it looks like pi's cancel. I get 10/18, and of course I can reduce that to 5/9. So that whole right-hand side becomes 5/9. X over 100 pi equals 5/9. And now I just need to multiply both sides by 100 pi. And I have x is equal to 500 pi over 9. I don't think that can be reduced at all for an exact value. Now my units here are units of area. So I'll write out the words. It's square meters. If you say meters, it's wrong. It's square meters, units of area. And let's also get a decimal on our calculators. That's about 174.5 square meters. And there we got it. So again, what's different here is we had to be aware that area is involved. There's really no shortcut to a proportion. There is a formula in the textbook. I don't like the formula in the textbook. I prefer you to set up the area proportion where we used radians instead of degrees in our setup.